Hey everyone, this is Yusuf, the Circuits TA, and today we'll be doing a problem where it's asking us to find the voltage values in our given circuit. As we can see in this question, they want us to find a lot of voltage values, and we're working with this circuit over here, question 41. Before we start finding our voltage values of our circuit, let's discuss voltages and good notation when talking about our circuits. So down here, I have three diagrams. This first diagram on the left side is a general circuit. We have our 10-volt battery, and we have a resistor. We're going to use this in combination with the other two diagrams to talk about voltage. Remember that voltage is talking about the electrical potential difference, usually between 2 points. And in a circuit, this potential difference, this voltage value, can show up as both positive and also as a negative number. So let's talk about what's the difference between a positive difference and a negative difference. So now I'm working with this diagram over here with Joey and Ross. If I say Joey's at 10 feet and Ross is at ground level or 0 feet, and I'm comparing Joey to Ross, I could say that Joey is 10 feet higher than Ross. If I was to represent this as a number, I would have a positive 10 feet, which would be my difference between their heights. Joey's at 10 feet and Ross is at 0. If I go to my third diagram over here with Rachel and Monica, and I'm comparing Rachel to Monica, I would say that Rachel is 10 feet lower than Ross, or lower than Monica. And so here I'm using different words. Here I'm saying lower, and on here I said higher. I'm going to have my same value of 10 feet, but this time I'm going to represent it as a negative. If I went back to my circuit, I could say the same thing about my circuit. If I'm comparing point A, which is right after my power source, this A node and wire is at 10 volts, and this wire connected to my ground node is going to be marked as 0 volts. If I'm comparing VAB, I can say VAB is 10 volts, a positive difference, so 10 minus 0 equals 10 volts. It's VA minus VB. But if I was to this the other way around, VBA to minus VAB, I would have a negative difference, negative 10 volts. So instead of saying A is higher than B, I'm now saying that, that B is higher than A. Just move this over. VBA is equal to negative 10 volts. And I can represent that as VB minus VA, which gives me 0 minus 10 volts. So now, after talking about that, I can go back up and start working on my problem above. In this problem, I'm actually going to redraw my circuit. And I'm going to redraw it in a way that I have my grounds connected. I can model it as one ground, or I can still keep both, but I want to show that these two are connected, and it should make sense. This bottom end of my battery is connected to ground, and this bottom end of my resistor is connected to ground, so they should both be connected. Okay, and for this problem, I have multiple options of going through it. I want to remember what we just discussed earlier about our voltage values. And here, I want to know a little bit more information about my circuit. Right now, I have two voltage sources. My goal is to, let's simplify this into one circuit, like what we had on the bottom with one voltage source. This 20 volt is pushing current clockwise, and this 47 is pushing current counterclockwise. And this is based off the position of our plus and minus. We're always thinking about we're going higher to lower. Because of this, I'm thinking 47 volts counterclockwise minus 20 volts clockwise. And my results will be a 27 volt battery going counterclockwise. So I can go ahead and draw that in this space right here. I'm going to go ahead and move this work down so we have some more space for this problem. Okay. So I have my 27 volt battery right here. And then it's okay if I move around my resistors in this case, because just right now, I just want to know some more information about my circuit. It's important to remember when I redraw a circuit, if I do redraw it, I need to make sure I match up my connections before I can take it back to the original. So for instance, this 27 volts, I can take this back to original if we're talking about the total voltage of our circuit. Here, now that I have my resistors, I'm going to actually add them up and find my R total. I have 4 kilo ohms plus my 3 kilo ohms plus my 2 kilo ohms. My R total is going to be 9 kilo ohms. Okay. I'm going to redraw my circuit one more time. I have a 27 volt battery and one resistor of 9 kilo ohms with a voltage drop across it. Okay. So here, now I'm thinking to myself, I can use Ohm's law. V equals IR. And I want all of my expressions in my Ohm's law to match up with each other. So here is going to be V total, which is 27 volts, equal to my I total times my R total. And my R total is given, or I just found, as 9 kilo ohms. I'm going to take my 9 kilo ohms to the other side and divide. I'm thinking about my prefixes. 27 divided by 9,000 will get me 3 times 10 to negative 3 amps, which is equivalent to 3 milliamps. This value right here, I can take this into my circuit, back to my original circuit, and help me find values on my original circuit. So this is 3 milliamps going counterclockwise, which should make sense because our voltage source is pushing current counterclockwise. I'm going to get rid of this. We have what we want. We have our 3 milliamps. 3 milliamps, draw it on this side. And now we can go back to our circuit and start finding voltages. Here, if I'm thinking I want VA, I can go ahead and start with that. Remember that our ground node is right here. So, and for looking at our voltage source, we're going 20 volts above ground to get to A. So VA is a pretty easy node to find. VA is going to just be 20 volts. Another easy node I see that we can discover is VE. VE is connected to our ground node on this side, and that's telling me that this is represented as ground, and VE is going to be 0 volts. I'm going to cross them off of our list, and now we can keep on analyzing our circuit. So like we just found out, we have 3 milliamps going counterclockwise. And now we can talk about the drops across our resistors. So remember that depending on the direction of current is how we determine those pluses and minuses on our resistors. We're going higher to lower, so we're going to drop across our resistors when we go this right to left direction or counterclockwise. So I'm going to think about Ohm's law again. V, and this voltage is going to be of the resistor, times the total current, times that resistor value, okay? I can do this for all 3 resistors. So the voltage of my 3 kilo ohm resistor is going to equal 3 milliamps times 3 kilo ohms. And this will give me 9 volts. Here I know my 10 to the negative 3 and my 10 to the third will cancel out to give me just base units of volts. So I can mark this. This is 9 volts right here. And that's a connection C to B. So I know this is 9 volts for V 3 kilo ohms. I also know that this is VC to B. I can follow the same process for my other 2 resistors. The same current because it's a series circuit. 3 milliamps times my 2 kilo ohms. I'll get 6 volts. And V4 kilo ohms, 3 milliamps times 4 kilo ohms will give me 12 volts. Now I know a lot about my circuit. To continue finding my other unknowns, I can go around and think about, am I going higher to lower? Am I dropping voltage? And what voltage am I starting at? So if I want to find the voltage at B, I can think about, okay, if I'm going at A, and I know A is 20 volts, am I dropping across the resistor, going left to right? Or am I going up voltage? So we know the current is going counterclockwise and that the voltage is dropping counterclockwise. So we know that B should be higher than A. Okay? So B should be higher than A because we're dropping counterclockwise. And we can also model it with this V 2 kilo ohms is B to A. I have now found a lot of values for my circuit that I need. I have the voltage drops across the resistors when I know that the current is going in this counterclockwise direction. So I know if I'm looking from this position of higher to lower, C is higher than B, and I'm dropping 9 volts. Knowing that I'm dropping voltage across my resistors when going counterclockwise, if I was to go clockwise, the opposite is true. So if I'm starting at A at 20 volts, instead of dropping 6 volts, I'd go up 6 because of what I know about the current. So an equation I can write is VA is equal to 20 volts. I'm going up 6 to get to 26 volts. And that is going to be my nodal voltage for VB. If I look at my signs, at my resistors, that should make sense. The negative and positive tells me which side is higher, which side is lower. This positive next to the B tells me that the voltage is higher at this side of the resistor, or at B. Similarly, when I look at my VBA of my resistor, this is a positive 6 volts, saying that B is higher than A by 6 volts. So if I was to do the double subscript notation for that, it's 26 volts minus 20 volts, and that'll get me 6 volts. So I proved my method in 2 ways and saw that my results made sense and they equal each other. So I can do the same method for every single node. So I'm going to update our diagram. We found VB. We still need to find VC and VD for our nodal voltages. I'm going to change colors again. Here, I'm thinking about B to C. B to C, I know going from counterclockwise C to B that I dropped 9 volts. But here, I'm going the opposite direction. So instead of dropping 9 volts, I'm going to add 9 volts to VB. So VB plus 9 volts, I'm going to get 26 plus 9. I know that VC equals 35 volts. 35 volts, okay. I can cross out another one of my nodal voltages. And now my next one is going to be VD. This one is a little bit different. Now we are working with our voltage source. So for VD, we're working on our voltage source. Because I want to know what VD is, I'm actually going to start by looking at my resistor, and then we can get back to our voltage source. And that will help us prove it in multiple ways. So if I'm looking at my resistor and I'm thinking current's going counterclockwise, if I'm going E and dropping 12 volts, and I know E is 0, I'm going down 12 volts from 0, I know VE should equal negative 12 volts, okay? So I can cross that out. Okay. VD equals 12 volts. And that solves all my nodal voltages. If I wanted to talk about my battery, my voltage source of 47 volts, I can talk about it in 2 ways. I can say voltage C to D and voltage D to C, okay? And once again, I'm going to look at my minus and positive signs. This negative sign at my voltage source is telling me to an extent that this side is lower. I know that D should be lower because I'm putting in 47 volts from D to C. So C will be at a higher voltage compared to D, and I already know that voltage value. So if I'm doing this double subscript notation down here again, I'm thinking VC minus VD, which is 35 volts minus a negative 12 volts, which would equal 47 because you add when you have a double negative. And that should make sense because we're talking about our battery, which is 47 volts. VDC, you'd flip it around. We're comparing D to C. I'm asking how much higher is D compared to C. The answer is D is not higher compared to C. D is actually lower. So we will get a negative 47 volts. And this comes from the math, negative 12 volts minus 35 volts, which gives us negative 47 volts. This same method can help us find all the voltages as asked for. VAB we already discovered, and VDC we already got. So now we need VCB and VDB. VDB, if I'm looking at my circuit and the connections, we're starting here and we're going to this resistor over here, okay? Once again, if I'm phrasing it, how much higher is node B compared to D as in Dylan compared to B as in Bob? I'm thinking, let me look at my values. So I'm right here, VDB is equal to negative 12 volts minus B, and we said B is at, I believe it was at 26 volts. So negative 26. So we get this, and this tells me that D is actually lower by 38 volts compared to B. Last nodal voltage I need to solve for, VCB. I'm going to do the work in this right corner, VCB. I'm going to do the same double script notation of work. I know my C nodal voltage, and I know my B nodal voltage. And what I'll get is that drop across resistor. 35 volts minus 26 volts gives me 9 volts. And now we have successfully calculated every single voltage.